class, today we're going to be covering lesson 9.4, which is still solving quadratic equations, only this time we're going to be using a method called completing the square. So I guess I would call this method number 3 because we've already learned how to graph and we learned how to use square roots. So if we take a look at number 1, this is a really good example of why do we need this, okay? So if we were going to try to solve this, and I'm just using an extra piece of paper here, so just to kind of show you the need, if we were to try to factor this first problem, we know it would be x times x, and since 5 is prime, we'd only have the one option. And we know our symbols are both positive or both the same, and then we would look back and we know they're both plus. But if we check our outers and our inner, we don't get the right middle term. So notice this problem cannot be factored. Now, we could go to graphing, but I want to show you how to do this in a different method. Now, I like the method of graphing for checking. So please feel free to use it as a way to check. But when you turn problems in or you turn things in, you're going to need to show your work. So please make sure you practice the proper method. Over here in the box is the steps. So if you get lost or confused, you can pull this up and take a look at them. I know it might be a little bit hard to see in the projection, but remember, all hard copies of these notes are also posted online. But right here, kind of at the very bottom, this is kind of the key. What we're going to try to do is we're going to try to create a perfect trinomial because we know how to factor a perfect trinomial. We did that in lesson 7.7. And then once we get it to a perfect trinomial, so once it looks something like this, equals a number, then in lesson 9.3, they showed us how to solve it. They showed us that we could take the square root of both sides. So this is kind of what we're working towards. And this piece right there at the very tail end, which is just b over 2 quantity squared. This is going to be the key. This is how we're going to create that perfect trinomial. And again, I think sometimes you just have to kind of see it in action. So let me show you number 1. I know I cannot factor this, so I need to solve it. So to do completing the square, the first thing I'm going to do is move the 5 to the other side. That's part of completing the square, that you need the constant on the other side. So let me rewrite this. Now, as I'm rewriting it, I'm actually going to leave a little gap right here. That's intentional. This little gap is going to be for this formula. Now remember, this is my A, my B. I can write it for you, A, B, and C. So my formula tells me to take half of b and square it. So I'm going to go half of b and square. But there's an old rule in math that says whatever you do to one side, you have to do to the other. So we're going to have to do the same thing on this side. Like that. Now let's just work this out. So let's work out this piece in red. So half of 8 is 4. And then 4 squared is 16. And then we know that this number is the same because whatever we add to one side, we have to add to the other. Okay? Now, this side I can clean up really quick. Negative 5 plus 16 is 11. So I can clean that up pretty fast. Over here, this has created a perfect trinomial. So what I'm going to do is go ahead and factor this down. So I know this is going to be x times x, and 16, I know I have a couple options. I know I have 1 and 16, I have 2 and 8, and I have 4 and 4. But if this is a perfect trinomial, that means I need the same number. So I would need this to be 4 times 4, plus I need it to become an 8. So that means this must be x plus 4 and x plus 4, and then look at that. Do you see how those parentheses are exactly the same? So what I can do is I can put those together. I can say x plus 4 quantity squared. And now that's going to equal 11. And so what I've essentially done is I've created a problem that looks exactly like what you did yesterday. And so now that you have the square alone, you're just going to take the square root of both sides. And so the square root is going to cancel the square, and so you're going to be left with x plus 4, but now we have to take the square root of 11. So let's grab our calculator, and we're going to go square root of 11. And notice how it's kind of a long decimal. Let's just round maybe to like 2 decimal places. So I'm going to say that this is 3.32, okay? But remember, whenever I take the square root, not only do I get the positive, but I also get the negative. So this is also a negative 3.32. Now realize we have rounded a little bit, but I don't think in our class it's going to make that big of a deal. So let's go ahead and subtract 4. So I'm not going to do that in my head. 3.32 minus 4 would be about a negative 0.68. And then over here, I'm going to subtract 4, and then that one I can do in my head. That's a negative 7.32. So here are my 2 solutions. Now, please remember what it means to be a solution. If we were to graph this, that means it's crossing at like a negative 0.68, and then it's crossing way down here at like a negative 7 point something. And then we know that it's positive because, we know it's opening up because A is positive. So it's probably going to look something like that. Now we could find the vertex, we could find the axis of symmetry, but they're not asking us to. Now I told you at the beginning that I don't mind if you want to use graphing, but remember to use it only to check. So let me pull up Desmos, and I'll go ahead and type this in. Desmos is a great tool because it's really quick, and when you hover your mouse over top of the points, see how it just comes up so fast. So there's our negative 0.68, and then here is our negative 7.32. We rounded, okay? So please feel free to use Desmos. It's a great tool to use to see if you're doing them right before you submit them. But any work that you would be turning in for us, we will require you to show these steps. So please make sure that you're going through and trying it. So why don't you pause the video here, and why don't you give number 2 a try? All right, hopefully you tried number 2. If you want, you could just, check your answer in Desmos. So I'll bring it up and I'll show you real quick here. So minus 12x minus 10. Oh, look at this one though. In this particular one, do you notice that it doesn't show up on my Desmos right away? So if I just zoom out, oh, there it is. I can see it now. So now I just had to adjust it a little bit. So there's one of my answers. And then my other answer looks like it's a little bigger than 12. Okay, so if you got these 2 answers, feel free to fast forward on to number 3. If you did not get that answer, then go ahead and watch the video and I'll do it with you here. So I'm going to move the number 10 over to the other side. I'm going to intentionally leave that little space or that little gap. And now I'm going to run my formula that I have up here in this corner. So I'm going to take half of 12 divided by 2 squared. Now you might be wondering, is it always a plus sign because the 12 was negative? Remember that whenever you square something, it's going to turn positive. So technically this negative right here isn't really going to make a difference. So we can just say plus, and then if you want, you can just drop the negative like that. So see how I didn't even put the negative, or you can include it. But when you square it, it's going to go away anyway, so it doesn't really matter. So we've got x squared minus 12x, and then this would be 6 squared. So 6 squared is 36. And whatever I add to one side, I just have to add to the other side. So I don't even really have to recalculate this. I already know what the number is going to be. And then if you want to work this out, that's going to be a 46. That right side kind of cleans up nice and quick. Now on the left side here, we're going to have to factor this down. And I told you that factoring is going to keep coming back up in parts of different chapters. So really is an important skill from chapter 7. So we're going to go with x times x. And then 36 is perfect. So we're going to use 6 and 6, but that also helps us get to 12. This tells me my signs are the same. When I look back, They're both subtractions. And so now I can write this as a duplicate because there's two of them. So I say quantity squared. And now this takes me right back to my lesson from yesterday from 9-3. So I'm just going to go ahead and take the square root of both sides. And that square root is going to cancel that square. So I'm going to be left with x minus 6. But now I got to work out the square root of 46 because I don't know that off the top of my head. So once again, it's a decimal. So let's just round this off a little bit. How about 6.78? But that also means we're going to get the negative. So we're going to get a negative 6.78. And then we're going to add the 6. So we get about 12.78. We got a little bit of rounding in there, but that's okay. And then we're going to add 6, and we get about a negative 0.78. And there are our two solutions. And that's the same numbers that we saw in Desmos, okay? All right, number 3. Number 3 really isn't any different than number 2, other than they've already done the first step for you. Do you see how the 18 is on the other side? So I just wanted to show you that it's really not any different. It's just the 18's already been moved over. Now, the only other piece that's kind of unique about this one, so let me just recopy it. Notice I just created that gap, is when we run our formula here, we're going to take half of the middle, quantity squared. So see, I'm doing the same thing as I did over here, just taking half that middle term. And remember, we just talked about the negative. If you want to drop the negative, it's not a big deal because you're going to square it anyways. But what is half of 15? A decimal, isn't it? Yeah, that's kind of unique here. So that's something I wanted to show you. So half of 15 is 7.5. Now we have to square that. So look at that. We're not getting almost like nice, clean numbers. We're getting decimals. So 56.25. Let me just write that on the other side here. That would be 18 plus 56.25. Let's just go ahead and add those together. So we get 74.25 on the right. Look at this. This is a perfect trinomial. That's so strange. I can tell you 36 is perfect. I know that one. That's 6 times 6. But what am I supposed to do here? So let's just try it. We're going to put our two binomials down just like we did over here. We're going to put our letters. So x times x. We're going to look at our symbol, and it's a plus. So we look back, and they're both subtractions. Now it's this number. Well, remember over here what we did? We just took the square root of 36. Remember up here? We just took the square root of 16. So why don't we just take the square root of that number? Let's just take the square root of 56.25, and let's just see what happens. This is 7.5, 7.5. So if I go 7.5 times 7.5, I know I get this number back. Let's check our outers and our inners. If we do the outer, we get a negative 7.5x. And if we do the inner, we get a negative 7.5x. So negative 7.5 and negative 7.5 is negative 15x. Hey, that's the right middle number. So even though this does not look like a perfect trinomial, it actually is. You still created a perfect trinomial, even though this is not a typical perfect number like 36, like 16, or like a 9, or a 25. This is still a perfect number. So we've got our two parentheses, so we're just going to put those together like we did before. And then we've got 74.25. And now, just like we did before, we're going to have to take the square root of both sides. And so this square root is going to cancel the square. And so we have 7.5. And now let's take the square root of 74.25. And once again, we got to round. So how about 8.62? But remember, we're going to also have the negative. I didn't leave myself a ton of space here. I'm just going to move down here a little bit. That would be a negative 8.62 as well. So I have the positive square root and I have the negative square root. Okay, just so you can kind of see how I've done those. And then now we just have to move this 7.5 to the other side. So we're going to go 8.62 plus 7.5. And there's one answer. And then we're going to still over here add the 7.5. So we're going to do negative plus 7.5. And we get negative 1.12. Man, that looks really strange. Like it looks like I might have done something wrong here. So let's give it a try and let's go ahead and test that Desmos again. Now just remember though, in Desmos, I'm going to have to move the 18 back. I'm going to have to move that 18 over to the left. See how the 18 started on the right? In order to use this in Desmos, I'm going to have to move it over to the other side. So I'm going to have to put it back here behind that 15. So you can see how I've typed it in. And then let's take a look at our numbers. Negative 1.12 and then positive 16, say 0.12. That's exactly what we have on our other paper. So we know we've done it correct. So again, you definitely need to show this work. Okay, so we're not going to give you a lot of these problems because look at 3 problems. Look how much work I've shown on 3 problems. So you're not going to have a lot of these to do, but you definitely, there's a lot of work to be shown. Now, the very last one down here, if you can kind of see it squeezed in here, has a coefficient out front. So that's definitely something we need to talk about. When you try to complete the square, you cannot have a coefficient out front. So we're going to have to start this problem off by getting rid of that 3. So all we're going to do is we're going to divide everything by 3. We're just going to divide it all by the coefficient. And so we get x squared plus 2x minus 8 equals 0. So see how I just divided everybody. I didn't change the problem. I just, in a way, kind of got out the greatest common factor. But I did it to everybody. And now I can go ahead and complete my square. So if you want to pause it here to try this one last problem, go ahead. And then I'll go ahead and type in the answer. So if you haven't paused it, pause it here and try it. All right, let me show you the answer. And then just like normal, I'll go through the work. Let me just hit back to home so we can see it. So it's 2 and it's negative 4. So 2 and negative 4. Now, I will go through the work if you give me just a second for those of you who need help, but I want you to notice how these did not have decimals. Do you see how they came out to be whole numbers? That can happen, but do you see how the ones above were decimals? Sometimes you get decimals, sometimes you get whole numbers. But the last thing I just want to point out, and then I will show the work on number 4 for anybody who needs it, is do you notice how much easier it might be if the middle number is even versus if the middle number is odd? Because notice this number versus this number. That is a significant thing with completing the square. I don't love this method if I have an odd number because it's harder for me to recognize this. Notice this problem we have left. Do you see the 2? It's even. So I don't mind completing the square because I'm probably going to be able to recognize the number. If the number is odd in the middle, it's a lot harder to recognize it. I can still do it, I just kind of need my calculator, okay? So if you feel comfortable with this, go ahead and stop the video and try the homework problems. Otherwise, let me go ahead and go through number 4 for some of you who need it. We need to move the 8 to the other side. And so as I recopy this, I'm going to intentionally leave that little gap there. So now I can run my formula. So remember, the formula is you take B, so this is your B, and you do half quantity squared. It's just a lot of 2's everywhere. But I'm taking half of B, so B divided by 2, quantity squared. And now I have to do that to the other side as well. All right, so this is going to be Half of 2 is 1. 1 squared is 1. And so now I do the same thing on this side. And then if I go ahead and add the right side together, that's nice and quick. And now I'm going to factor this down. So I'm going to do x times x. 1, wait a minute, that's only 1 times 1. This tells me my symbols are the same. So when I look back, they're both plus. And just quick, check your outers and your inners if you don't feel confident. So my outer would be a 1x. My inner would be a 1x, which means that's a 2x. So I know I've done it right. Okay, so I know this is factored correctly. And I'm just going to move over here because I don't have a lot of space. My parentheses are duplicated. So I have x plus 1 quantity squared. So I just put those together. That's all I did was just put them together. And now I'm going to take the square root of both sides. And so the square root is going to cancel the square. And so I'm left with x plus 1. But now I have to take the square root. Now this is nice because the square root of 9 is just 3. But remember, it's not only positive 3, it's also negative 3. So you do have to do both, the positive and the negative. And now we're going to subtract 1. And then we're going to subtract 1. And notice my two answers are the same as what we saw from Desmos. Okay? So that completes the lesson on how to complete the square. So go ahead and practice the problems on the homework page.